Okay, hi guys. So in this lecture, we'll be first seeing a small topic which is called Friens rearrangement. So let's get started. So we have Friens rearrangement. Okay. So let's suppose we have uh, OCS3 here, and in presence of AlCl3, we get this converted into something like this compound of phenol and keto group attached here. Okay, so we have to study how this rearrangement took place here. So this is nothing but a phenoxyester. So what happens here is, first we pass AlCl3 on it. So in the first step, what will happen is, obviously we'll be getting something like this: O plus AlCl3 minus and C double bond O CH3 here. Next, what will we be getting? This oxygen atom actually takes back the bond electrons from the carbon atom, making a positive charge here at the carbon atom. And why would it be stable? I keep that as an open question. Rather, not an open question, question for you guys to tell the answer to. We have this compound, why would it be stable? Obviously because of formation of our IIT cation. Okay, so this benzene thing will act as a nucleophile on this carbocation. Okay, why it is not attaching itself to the ortho position? Due to obvious steric hindrance reasons. Hence, as this compound would be orthopara directing, this is not O plus anymore, it would be orthopara directing, hence it will be directing it to ortho and para positions, and at ortho positions we have steric hindrance, hence we are not attaching this compound here, hence the only possible position left is para position. Okay, some little bit of heating may be required, because to extract the H from this carbon atom we require heating, and again restoring the aromatic character. Then in H plus, what will happen? We'll get something like this compound. Okay, so this is how Friens rearrangement took place in this example. Let's take another example wherein we have something like this compound and H and O2. Okay, and this is reacting with H plus and we are heating it. So what will happen in this case is, the lone pair from nitrogen would be attacking to this H plus, and as a result we would be getting something like NH2 plus and NO2 here. This will soon be taking its bond pair away from the nitrogen atom of the NO2, and as a result we'll be getting NO2 plus. Okay, now again this aniline is ortho and para directing, it will attack the para position, will attack the NO2. Obviously, why? At ortho positions we can also attach it, but the major product I am showing that at the para position there are more chances for NO2 to get attached. Okay, and this would be the major product on heating this. Okay, so we are done with the Friens rearrangement. Now let's get started with the new topic, which is called carbonyl compounds. Okay, so carbonyl compounds are nothing but the aldehydes and ketone. Okay, carbonyl compounds, and specifically those are nothing but aldehydes and ketones. Okay, so let's get started. So first we'll be seeing the preparation of aldehydes and ketones. We'll be seeing preparation of aldehydes and ketones. We have seen so many examples in the past lectures wherein we talked about the preparation of aldehydes and ketones. Okay, so it would be a easy thing for us. The first is from we RCO2H, okay, plus we add CaO, BaO and heat to form aldehydes and ketones. So what is the actual reaction looks like is something like we have carboxylic acid, we heat it in presence of barium oxide and calcium oxide. So what will we be getting? We will be getting something like a ketone. Okay, so how does this reaction takes place? So consider like this, we have two molecules of RC double bond OH, which in contacting with CaO forms calcium carbonate, or rather let's first remove the water molecule. Okay, now water molecule is removed. Now what will we be getting? We'll be getting something like this compound. Okay, now we remove CaCO3 from this reaction. So let's actually make CaCO3. CaCO3 would be nothing but CaCO3. Okay, one carbon, 3 oxygen and one calcium atom. So when we remove it, this R would be obviously will be getting attached to this carbon atom. Okay, so okay, this will be leaving as a minus and will be having a partial, or will be having a positive charge when the oxygen atom leaves this carbon atom. So negative and positive, again making a bond between the two of them. Okay, so this is a positive charge. Okay, so hence CaCO3 is formed, rather RCOOR is formed. Okay, let's discuss another example. So we have RC double bond OH, we are hitting it in presence of we have already seen this reaction. Let's take PHCOOH rather, benzene carbonic acid, and let's have acetic acid as well and presence of CaO, and we heat it. So how many products would be getting formed? So one thing is CO3 gets, this carbon atom gets removed from as a CaCO3, and this pH actually gets attached with itself. Okay, so we'll get something like this, or this pH attached on this carbon atom, so we'll be getting something like this. Okay, next what can be the case? We can also have we'll be seeing the situation wherein this CH3 will be getting attached to itself. Okay, so we'll be getting something like this situation, and the final one would be this CO3 getting attached to this carbon atom, so we'll be getting CH3 CO double bond O pH. But this is similar to this one, hence only 3 products are the ones which we get after reaction of these two with CaO and when we heat it. Okay, what happens in this case when we have something like CH2 C double bond OH and C double bond OH, and we heat it in presence of calcium oxide. So what will we be getting? First step would still be the same, wherein dehydration of water molecule takes place. Okay, and next calcium oxide would be, calcium carbonate rather would be leaving the compound. Okay, this would be the structure, and then what will happen is calcium carbonate would be leaving the compound. So what will we be getting? We'll be getting something like bond between this and this. So how many member ring is there? 1 2 3 4 5. So finally we'll be getting something like a cyclopentanone. Okay, so So by the way, let's just discuss the common names of the products of the previous reaction. This compound is known as acetophenone. So why I'm telling you the names of this compound, because in some of the questions, comprehensive questions, some names are actually given for the compounds rather than the actual structures. So it may be useful for you to just remember the name, so it becomes easy for you to correlate that with the compound. Okay, this is nothing but acetone, and this is pH, C double bond O, pH is benzophenone. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing the preparation of aldehydes and ketones from alkenes. Okay, till then, good luck and goodbye.